All right, welcome back. Today, we're going to get our hands dirty and dive right into API 570, specifically Chapter 8. This is all about repairs, alterations, and re-rating. You know, this is where all that theory smacks right into reality. And we're going to break down the exact steps you need to follow to keep your piping system safe and, well, in service.
So, let's just imagine for a second. You're on the job, and an inspection just flags a defect in a really critical piece of piping. The clock's ticking. What's your first move? Where do you even start? Well, that's exactly what Chapter 8 is for. It's the playbook for this exact situation, giving us a clear roadmap from finding the problem to fixing it for good.
So here's how we're going to tackle this. First, we'll talk about getting the official green light to even start the work. Then we'll look at the big decision, temporary versus permanent fixes. After that, we'll get into the nitty-gritty of welding and heat treatment, how to test the repair once it's done, and finally, we'll cover how to re-rate a system for new conditions. Sound good? Let's jump in.
Okay, first things first. Before anyone even thinks about picking up a tool, you absolutely positively have to get the green light. And this isn't just about shuffling paperwork, you know. This is the bedrock of a safe, compliant repair process.
This right here is the golden rule, straight from Section 8.1.2, and there's no way around it. The inspector has to authorize all the work before it kicks off. And look, it's not just red tape. This is a super important control point that makes sure every single repair is tracked, justified, and follows the code from the word go.
And what's really interesting here is the clear split in responsibilities. See, the inspector gives the go-ahead to start the work, but it's the piping engineer who approves the technical how-to. They're the ones signing off on the design, the materials, the welding procedures, the whole shebang. So think of it like this. One person says, go, and the other says, here's exactly how you'll do it. Okay, so you've got your approvals. Now you're staring down your next big decision. Are you going to put in a temporary fix to keep the plant running, or is it time to plan for a full-on, permanent repair? The code actually gives us some really clear guidance on how to make this call.
So you've really got two main paths. A temporary repair, like a clamp or a patch, is basically a strategic move to buy you some time, maybe avoid a costly shutdown. But the key thing to remember, and the code is very clear on this, is that it has a shelf life. It has to be replaced with a permanent fix later. A permanent repair, on the other hand, well, that's all about making the pipe good as new, completely restoring its original strength.
And check this out. This example is pulled right from the code. For a temporary fillet welded patch, you can't just wing it and guess the weld size. Nope. API 570 gives you a very specific formula to use, and that tells you something really important. Even a temporary fix doesn't mean it's unengineered. Every single repair needs to be backed by solid engineering.
Now, let's compare that to a permanent flush patch. The standards are way, way higher. We're talking full penetration welds. And for critical systems, those welds have to be 100% checked with either radiography or ultrasonic testing. Even the shape of the patch is spelled out. You have to have rounded corners. And why is that? It's to reduce stress concentrations. Sharp corners are just asking for trouble. They can easily become the next spot to fail. The level of detail here is all about making that pipe whole again.
All right, now we're getting into the real heart of most repairs, the welding. This process pumps a ton of heat and stress into the metal, and knowing how to manage those effects is absolutely crucial if you want a repair that's going to last.
And that's where post-weld heat treatment, or PWHT, comes into play. The easiest way to think about it is like a stress relief spa day for the metal. After welding, you carefully heat the area up, hold it at a specific temperature, and then let it cool down nice and slow. This whole controlled process basically relaxes the metal, gets rid of all those stresses locked in by welding, and seriously lowers the risk of it cracking down the road.
That's a great question, right? Because in a perfect world, you'd probably do PWHT on a lot of these welds. But what happens when you're working in a tight spot, or the component is just weird, and a full-blown PWHT is impractical or maybe even impossible? Does that just mean you're stuck? Well, the good news is the code has a backup plan. Section 824 gives us a very clear decision tree to follow. If PWHT is supposed to happen but you just can't do it, the piping engineer can look at and approve an alternative. The two main options you've got are the preheat method and the controlled deposition welding method, and both of these are pretty specialized techniques. So if you're thinking about PWHT alternatives, there is one number you absolutely have to burn into your brain:
300 degrees Fahrenheit or 150 Celsius.
This is the minimum temperature you have to keep the metal at while you're welding if you're using the preheat method instead of a full PWHT. See, by keeping the metal hot, you slow down how fast it cools. This stops brittle, nasty structures from forming in the weld, and you end up with a similar stress-relieving effect. It's a really clever workaround. So, the weld is done, the heat treatment is finished, the job looks fantastic. But how do you prove it's safe? That's where post-repair testing comes in. This is the final exam, the ultimate verification that the repair actually did its job and restored the integrity of the system.
This is the million-dollar question that every single engineer and inspector has to answer. It's not enough to just go through the motions. You have to validate the final result. This last check is what gives everyone the confidence they need to put that system back online and under pressure.
Now, Section 8.2.8 is pretty clear that a pressure test is the default, especially after major repairs. But let's be real, sometimes a full pressure test just isn't practical. In those situations, you can substitute it with the right kind of non-destructive examination, or NDE. We're talking 100% RT or UT. But, and this is a big but, this is not an easy way out. You need formal sign-off from both the inspector and the piping engineer to go this route.
And last but not least, let's talk about re-rating. Now, this isn't about fixing something that's broken. It's about taking a fresh look at an existing asset to see if it can be safely used under totally different conditions. Get this right, and you can save a ton of time and money.
So, what exactly is re-rating? Well, it's a formal engineering process to change a system's operating limits, either its design temperature or its maximum allowable working pressure, its MAWP. The real key here is that all the calculations are based on the pipe's actual current condition, how thick it is today, not what it was like when it was brand new.
But you can't just run a few numbers and call it a day. Oh no. Section 8.3 has some very strict rules. An engineer or inspector has to do the calculations and sign off on them. You need current, up-to-date inspection records that prove the pipe is still thick enough. And this is a big one. You need documented proof that the system has already passed a leak test at a pressure that's as high or higher than what the new rating would require.
You know, this quote, right from the beginning of the chapter, really ties everything we've talked about together. It's the North Star. Even though API 570 gives us the rules for in-service work, it's constantly pointing us back to the original construction code, like ASME B31.3. It's a powerful reminder that every repair has to respect the engineering foundation that the system was built on in the first place.
So I'll just leave you with this thought. Following the rules in API 570 makes you compliant, sure, but compliance is the floor, it's not the ceiling. The real goal is long-term safety and integrity. So the question is, are you just using these rules as a checklist? Are you really digging into the engineering principles behind them to make sure your assets are truly safe for the long haul? Thanks for joining me.